We're going to look at how to build a probability distribution for this example, where we have, we're looking for a probability distribution for the number of heads when you flip a coin 2 times. Before we build a probability distribution, it's very helpful to just define what our variable is. So I'm going to use the uppercase letter X as the name of my random variable. And my random variable would be the number of times heads comes up when you flip a coin two times. So to investigate this, the first thing I'm going to do is think about, well, what are all the possibilities that could happen with this experiment? So let's think about, I could flip the coin first and I get a heads, and then I flip it again and I could get another heads, or I could have that same heads and flip it and get a tails. Or I could flip and get a tails the first time and then a heads on the second one, or a tails the tails the second time, sorry, tails the first time, and then get a tails on the second flip. Those are all the possibilities of what can happen. And so when I think about the number of times heads could come up, well, because I'm flipping the coin twice, so when I think about my little x's, okay, and I'm going to build a table of x's and their associated probabilities. So when I think about the number of times heads comes up when I flip a coin twice, well, it could come up 0 times, it could come up 1 time, or it could come up twice. Those are all the possibilities of my x. And then I'm just going to count how many heads I have here. I have 2 heads in this case, I have 1 head in this case, 1 head in this case, and 0 heads in this case. And my total number of possibilities is 4. To figure out my probability of each of these, I'm going to say, well, let's look at 0 heads coming up. How often did that happen? It happened here, so it happened once, so there was 1 0 out of 4 tries. And so that gives me a probability of 1/4, or I can put it, so I can leave it in fraction format, or I could put it in decimal format. And then I look at the next one. What's the probability of getting a 1? Well, how many 1s did I get? There's 1, there's 2, so I got 2 1s, and I divide that by 4, and I get 0.5, so 2/4, or 0.5. And then I look at how many times did I get 2 heads, and that's only once, so that again is 1/4, or 0.25. And just to be super safe, I want to look at this and say, okay, if this is supposed to be a probability distribution, each of my values has to be between 0 and 1, each of my probability values, that is, and I check those. And so I say, yep, that one's okay, that one's okay, that 0.25 is between 0 and 1, 0.50 and 0.25. And then I'm going to add these up, okay, I'm going to add these up and verify that they come out to near or exactly equal to 1. And so that becomes 5 and 0 is 5 is 10, carry the 1, 0, so it comes out to exactly 1.0. So this is a valid probability distribution. And so to summarize the process that I went through, the first thing that I did is I defined my variable. The next thing I like to do is figure out what are the possibilities of that I could have as a result of this experiment. And I like to then fill out my x's next. Okay, I could have 0, I could have 1, I could have 2. The third step was to model all of the possibilities. And then from that, I can calculate my probabilities. So now imagine if the question were, build a probability for the number of heads when you flip a coin 3 times. Okay, so let me give myself a little bit more space here. Actually, I'm just going to switch to a different color. So imagine I could flip a coin 3 times. I would follow the same process, right? What could my little x values be? They could be, I get no heads, I get 1 head, I get 2 heads, or I get 3 heads. And there are just going to be more possibilities. And I can do a tree diagram, or I can just list them out, right? I could have a heads and a heads. I could have all heads, or I could have a heads and a tail. And so on. And you just have to list all the possibilities. And you know how many there should be, right? Because if you think about counting, there are 3 possibilities for the, hang on a sec, let me just erase this. There are 2 possibilities for the first flip. There are 2 heads or tails, 2 for the second, 2 for the third. So there should be, our n should equal 8. So you should come up with 8 different possibilities for that. And I'm going to end there. We've seen how to build a probability distribution for the number of heads when you flip a coin 2 times, and a little hint as to how you would start if you were looking at how to flip a coin 3 times.